Okay guys, I'm going to look at a short video on calculating and how to calculate relative formula mass. Okay, sometimes abbreviated RFM, RMM, RMR, so all those three terms you need to be aware of, all pretty much at GCSE mean the same. Okay, RMM refers to relative molecular mass, okay, but we use them pretty much interchangeably at GCSE. And we're also going to talk about percentage composition slightly later in the video. Okay, so first of all, what is the relative formula mass? Well, it is the mass of 1 mole of something. I convert it into grams. Now, what is 1 mole of something? Well, 1 mole of something is the mass number of it, if it is an element on its own, or the combined or cumulative mass numbers of all the elements in something, if it is a compound or a element containing more than one atom. So, what I mean there, if I took sodium, okay, and we look at the two numbers in sodium, we have this number, the top number, which is the mass number. Okay, now that mass number is, of course, the number that we use to calculate the relative formula mass, or the relative molecular mass. So the mass of 1 mole of sodium is 23, so the relative formula mass is 23 grams. So the relative formula mass, the mass of 1 mole of sodium, is 23 grams. Okay, if I was to take something, another elements, for example, oxygen, O2, okay, and this time we have 2 oxygens which we need to be careful of, okay, and each oxygen is 16, so the relative formula mass of oxygen is 32 grams, 2 times 16. So they're very, very simple examples. Okay, let's make it a little bit more difficult. So if we took, for example, sodium chloride, then where we've got a formula of 1 Na and 1 Cl in a compound, we take the sodium mass number, that's 23, and we've got one of them, and we do the same for the chlorine, which is 35.5, and again we've got one of those. Okay, and that gives me a relative formula mass of sodium chloride of 58.5. You can, maybe a good idea guys, just to stop the video, and as I do these, once you think you've got the hang of them, and then just do them yourself to double check that you can get them right. So if we took then, let's say, magnesium fluoride, formula MgF2, this time we go to the periodic table again, so make sure you've got a periodic table with you. Find magnesium at 24, find fluorine at 19 here. So we do our 24, we've got fluorine which is 19, but you've got to remember you've got 2 of them, okay, so that is 38, okay, so we have an RFM of magnesium fluoride at 62. Okay, then if we took potassium, let's say take potassium oxide this time, K2O, so it's important guys that you're able to use your crossover arrows and work out your formulas, of course, in this. Okay, so we've K2O, so this time we've got 2 potassiums, and if we go to the periodic table, we'll find potassium mass number 39, okay, times 2 gives us 78. We have just 1 oxygen, which is 16. Okay, so the RFM of potassium oxide is 94 grams. So those are all pretty simple, okay? 2 elements joined to each other. We'll make it a little bit more difficult now, and that we'll start to use maybe some brackets and some polyatomic ions. So let's take one where we've got calcium hydroxide perhaps, and now we're into, at the reverse side of the periodic table, using our polyatomic ions from here. So how do we do that? Well, we've got 1 calcium, which is 40, we've got 2 16s, which is 32, and we've got 2 hydrogens, which is 2, so if we add those all up, we've got a total then for calcium hydroxide of 74. 74. Okay. Right, if we took then, let's say a slightly more difficult one again, and we'll take ammonium, we'll take ammonium carbonate. So our 2 here tells me I have 2 nitrogens, which is 28. I have got 2 times 4, which is 8 hydrogens, gives me 8 times 1, we have a carbon at 12, and we have 3 of our oxygen, so we have 16 times 3 in that case. Let me just top that up. So we've got 28 plus our 8 plus our 12 plus 8 gives me an RFM of that of 96 grams. Okay, so we'll do one more of that. Okay, and hopefully you'll have grasped the concept by then. So let's take a one with water of crystallization. So let's take Cu, that's a U, sorry, CuSO4.5H2. So the dot tells me I have 5 of everything that comes after it. Okay, so our copper, if we go to the periodic table, is 64. Sulfur is 32. We have 4 oxygens to deal with, okay, which is 4 times 16, which is 64. And the quick way to do this is I have 5 waters, and it's a good idea to know the RFM of water off the top of your head. Okay, so water is an RFM of 18. Okay, so we do 5 times the 18 is 90 in total, and if we add all of that up, we get total RFM of that compound comes out at 250 grams. So that's how you deal with what we call dot formulas and RFMs of them. Okay, so that's, guys, really how you work out RFMs. There's lots of examples in your notes, so use those. I'll just do another video actually on percentage composition, but hopefully that will clear up how to work out RFMs and, in other words, the mass of 1 mole of something.